Hello, I'm Kayla Flager, and I'm here to talk about the pasta rocket experiment. This experiment was really cool. Basically, we were going to take a jar and combine yeast with hydrogen peroxide to see essentially what reaction occurred. So we had a guide video posted on Blackboard that really laid it out nicely for us, and I was really looking forward to getting started with this. We needed just a couple of materials to complete this experiment. We did need a ziti noodle, or it could have been any pasta that has a hole running through it, and this was used to light on fire and see what reaction takes place. We needed a mason jar with a lid. We just used the solid part of the lid. We didn't use the mouth because we didn't want to create any extra pressure inside of the jar. It could potentially cause an explosion, which we definitely didn't want to happen. So we also poked a hole in the lid. Needed hydrogen peroxide, yeast, and a lighter. This experiment was easy to set up. I put some hydrogen peroxide into a jar and I did pour the yeast into it. The next step was to kind of create a seal with the top part of the jar. It's lined with rubber, so you just kind of push it down on top of the jar and make sure it has a little seal. Then you shake up the yeast and the hydrogen peroxide and can observe what happens from there. So after I shook up the yeast and the hydrogen peroxide, I did place the noodle on top of the hole that I poked into the lid. And as I did that, the gas that was a result of this reaction came up through that noodle. It had a way to be released from the jar, and you were able to light that noodle on fire, and it kind of shows the flame coming out of the top of the noodle. The reaction that I had was really successful. It was really cool to see the flame constantly burning down as the noodle continued to burn. My results weren't quite as extreme as the results in the guide video, but I was kind of glad because it made me nervous and I was worried that, it would cause a bigger flame. And so I was really, really happy with the results that I had with this experiment. So let's talk a little bit about the science behind this experiment. So basically, hydrogen peroxide is in its natural state that we purchase it in. It is naturally dissolving in a decomposition reaction, or I should say decomposing, not dissolving, decomposing in a decomposition reaction. So this is something that's always taking place very, very slowly. I found out while doing some research that that is why the hydrogen peroxide is always stored in a dark bottle, because it helps to slow down that natural process that it's going through. So when we add yeast to the hydrogen peroxide, basically it rapidly increases the speed of the decomposition. When hydrogen peroxide is dissolving, it becomes oxygen gas and water. So when you add the yeast, it decomposes much more rapidly and more quickly becomes water, or H2O, and the oxygen gas. This experiment is exothermic because it does give off heat, and it should be noted that the yeast is not a reactant in this reaction. It just serves as a catalyst because it does advance the decomposition of the hydrogen peroxide into water and oxygen gas. The way that we see the flame kind of igniting with the release of the oxygen gas is simply just a result of that gas being released. Because we poked a hole in the lid, it had a way to be released from the container that it's taking place in. So it's naturally going to be released into the atmosphere. When we put the noodle on top, it's really just simply a way so that we can actually light it on fire without, burning ourselves. It gives us a substance to light on fire, so that way we can see that flame continuing to burn as the oxygen gas is continuously being released, just like you would with a rocket. essentially. It was funny because during the experiment, when I was getting to the end of the reaction and the flame was kind of dying down, the jar, even while the gas was being released, even kind of like stuttered like a rocket would if it was burning out. So that was really funny. So during this experiment, there were two types of bonds that were being formed from the hydrogen peroxide, which it was again decomposing into water, H2O, and gas. So the H2O is formed as a covalent bond, a polar covalent bond. We know that the bond is covalent because rather than ionic because it's two nonmetals that are bonded together. So we know it's covalent, and we also know that the bond is polar because the electrons between the hydrogen atoms and the oxygen atom are not being shared equally. They're going to spend a little bit more time closer to the oxygen atom in order to maintain that bond and its stability. So that bond of H2O is a polar covalent bond. Oxygen gas is being bonded to itself, and that is created by a double covalent bond. We know it's double covalent because the oxygens are sharing two pairs of electrons in order to reach that full valence shell. So this was a really great way to take a look at those different bonds and kind of see them in a more real life setting, and I really enjoyed it. Thanks for your time.